Hi everyone. In today's lesson, we'll be taking a look at some of the most basic and most common trig ratios in right triangles. So, in your notebook, please put down today's subtitle, which is Basic Trig Ratios in Right Triangles. There are three trig ratios which come up very often in mathematics. In order to understand our three trig ratios, please prepare the following right triangle. Go ahead, pause the video, and prepare it now. When dealing with trig ratios, we often look at the trig ratios from the perspective of a specific angle in the triangle. Let's investigate some of the most common trig ratios as they relate to angle A. The first trig ratio is called sine, and that is normally abbreviated as SIN. We say that the sine of angle A will equal to the ratio formed by the length of the side that is opposite of angle A. We usually denote that using the word opposite, versus the hypotenuse. And if we were to use the variables that have been set up for you in the diagram, that would equal to the opposing side, which is denoted by the small letter a, divided by the hypotenuse, which is denoted with the letter C. The second trig ratio that is extremely common is called the cosine, and that is normally abbreviated as COS. When we say the cosine of angle A, we are referring to the ratio formed by the length of the side that is adjacent to angle A. Normally, we would simply write the word adjacent, versus the hypotenuse. And again, if we were to use the variables that I've set forth in our diagram, the adjacent side to angle A is denoted by side B, divided by our hypotenuse, which is again denoted by the letter C. And the third trig ratio that is extremely common is called the tangent, and that is normally abbreviated as TAN. And if we say the tangent of angle A, then what we are referring to is the ratio formed by the length of the side opposite of angle A, which we normally denote as opposite, versus the length of the side that is adjacent to angle A, and that is normally denoted as adjacent. And one final time, if we were to refer to the variables set forth in the diagram, then the opposing side is denoted by the letter A, divided by the side adjacent to angle A, which is B. Next, I'd like to investigate these same three trig ratios, but this time as they relate to angle B. If we were to say the sine of angle B, then we are in fact referring to the ratio formed by the length of the side opposite of angle B, which is denoted by the letter B in our diagram, versus the hypotenuse, which is denoted by the letter C in our diagram. If we were to say cosine of B, then we are in fact referring to the ratio formed by the length of the side that is adjacent to angle B. In our diagram, that would be denoted by the letter A, versus the hypotenuse, which is denoted by the letter C in our diagram. And finally, if we were to say tan of angle B, then we are in fact referring to the ratio formed by the length of the side that is opposite of angle B in our diagram, that is denoted by the side B, versus the length of the side that is adjacent to angle B, and in our diagram that is denoted by the letter A. Now that we have the three most common trig ratios as they relate to angle A and to angle B written down in front of us, we can make some very important observations. Perhaps one of the first things that most people notice is that if you look carefully at the trig ratios, you'll notice that the sine of angle A is equal to the cosine of angle B, and also the cosine of angle A is equal to the sine of angle B. This observation may lead us to conclude that if two angles are complementary, meaning that the sum of the two angles is 90, then the sine of one of the angles will be equal to the cosine of the other one. The second most important observation that can be concluded from all our trig ratios is that the sine and cosine of any angle will always produce results that are at most equal to 1. This is true because remember that sine and cosine are both ratios where the denominator is a hypotenuse. And remember that in a right triangle, the hypotenuse is always the longest side. So therefore, in the sine and cosine ratios, the numerator can only at most be equal to the denominator. It can never be larger. Therefore, the ratio formed by sine and cosine should always be smaller than 1 or equal to 1, but never larger, because the numerator will never be larger than the denominator. And the final observation, based on these trig ratios, is unfortunately harder to see, but very easy to prove. The third observation states that the sine of an angle squared plus the cosine of that same angle squared should always equal to 1. Hard to see, but easy to prove. So let's prove it. Well, we know that based on the trig ratios, the sine of angle A is equal to A over C, and if we were to square it, it should be written like that. Plus, from our above trig ratios, we see that the cosine of angle A is equal to the ratio B versus C, and again, to square that, we use our brackets and put our exponent 2. Now, if we were to simplify that by distributing the exponent, we would get that that equals to A squared over C squared plus B squared over C squared. To add our fractions, our denominators are already common, so all we have to do is add the numerators, giving us A squared plus B squared all over C squared. And thanks to the Pythagorean theorem, we see that A squared plus B squared should give us the hypotenuse squared, which is C squared, over C squared. And as you can see, C squared over C squared simply gives us 1. So very, very important property. Hard to see, but easy to prove. That's all there is, ladies and gentlemen, to 3 of the most common trig ratios in mathematics.